Hey everybody, in this video we're going to be solving right triangles to find unknown sides. If you want to follow along, the links to the companion worksheet are in the description below, so let's get started. Now one thing to point out is that we will be using approximate values in certain cases, and that's going to require the use of a calculator. And this brings up an important point about trigonometry, because this is the #1 source of mistakes and wrong answers. And that is, people enter in angles into sine and cosine and tangent on their calculator, but they don't realize that the calculator is interpreting it differently. And that is because we may mean a certain unit of angle, but the calculator interprets it differently. We are using degrees for all our problems here, and we need to be sure that our calculator is in that same mode. So here I've got a graphing calculator, a TI-83. So if I click mode, I want to be sure that it says degree. If not, I'm going to be getting wrong answers because the calculator would be assuming, if it looked like this, that I was entering angles in radians, not degrees. Now, if you have a scientific calculator, something like this, you don't actually have to go to a mode screen per se, because you can look on the edge of the screen, and usually either on the top or on the bottom it'll have something like D or DEG if it's in degree mode. If it's in radian mode, it'll say R or RAD. And so if you look around for a button something like DRG or angle, that will allow you to change modes. So here we have this right triangle, and we want to find x and we want to find y. Now we know the hypotenuse is 7, and we know this angle is 46 degrees. And x is the opposite side, and y is the adjacent side. So if I want to find the opposite side, I know the hypotenuse, so I'm going to use the sine ratio. So sine of 46 degrees is going to equal x over 7. So to solve for x, I'm going to multiply the 7 over. So 7 times sine of 46 degrees equals x. And for some teachers, this is an appropriate answer, especially if you don't have a calculator accessible. This is totally fine. But if your teacher wants an approximate answer, we'll type that into our calculator, and that is 5.035 for x. Now for cosine, cosine is the adjacent side. So that means we're going to be using the cosine ratio, because whereas sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. So cosine of 46 degrees equals y over 7. So we'll multiply the 7 over, leaving y on the other side. So 7 times cosine of 46 degrees equals y. And so as an approximate answer, y is going to equal 4.863. Now in the next example, we want to find this length of AD. The problem is that AD is not a side of a right triangle. It's part of the figure as a whole, but it's not actually part of a right triangle, because this is not a right triangle here. So the way we solve this is we have to recognize that there are actually two right triangles here. The first one is ABC, and this has an angle of 30 degrees and a side of 75 centimeters. The second right triangle, smaller, is DBC, and this has a side also of 75 centimeters, but this has an angle of 40 degrees. Now AC and DC are sides of right triangles, and AD represents the difference. So what we have to do is we have to find this side and subtract them. Now 75 is opposite the angles that we know, and x and y are adjacent. So in both cases, we're going to be using the opposite and the adjacent sides, and that calls for the tangent ratio. So in this triangle, tangent of 30 degrees is going to equal 75 over x. And for this triangle, tangent of 40 degrees equals 75 over y. Now we have to solve for x and y, and right now they're in the denominator. We need to get them out. So we're going to multiply by x and multiply by y. So x times tangent of 30 degrees equals 75, and y times tangent of 40 degrees equals 75. And so we're going to divide by tangent of 30 and by tangent of 40 in the other equation. And that's going to get x and y by themselves. So we have 75 over tangent of 30, and y equals 75 over tangent of 40 degrees. And since these are exact values, I can just go right ahead and say that AD equals 75 over tangent of 30, because this is what x is. This is the value of x minus 75 over tangent of 40 degrees. That's the value of y. And that's an exact value, but if we want an approximation, we can do that. So 75 divided by tangent of 30, and then I subtract 75 divided by tangent of 40. And what we get is an approximate value of 40.522 centimeters. Now the next one is more difficult, because here we do have two right triangles again, except that now we have two unknown sides, and we just know this. So let me draw out these two. Now unfortunately we don't have corner labels like we did in the last problem. So here I've got 37 degrees for this right triangle here, and this side down here is x plus 20. Now the other one is going to have a side of h. This angle is 66 degrees, and this side is x. And what we want to do is we want to solve for h. Okay, now we both have opposite and adjacent sides. So we have set this up as tangent of 37 degrees equals h over x plus 20. And we'll set this up, tangent of 66 degrees equals h over x. Now what we need to do is we need to solve for h. That's what we're trying to find the value of. Now what we're going to do first is we're actually going to solve for x. Now it sounds kind of weird, but you'll see why in a second. Right now we want to get x by itself. So what we're going to do is I'm going to multiply by the denominators out. So here I have quantity x plus 20 times tangent of 37 degrees equals h, and x times tangent of 66 degrees equals h. So at this point over here on the left, I'm going to divide by tangent of 37. On the right, I'm going to divide by tangent of 66. So I'm left with x plus 20 equals h over tangent of 37 degrees. Over here, I'm left with x equals h over tangent of 66 degrees. Now the last thing I have to do here is I have to subtract 20. So x equals h over tangent of 37 degrees, and that whole thing we're subtracting 20. Now why did we solve for x? Because both of these are equal to x, and x is always equal to itself, that means that this has to be equal to this. So when we write this down, we have h over tangent of 37 degrees minus 20 equals h over tangent of 66. So now we have one equation with one variable. Now one thing I'm going to do to make this a little easy is I'm going to go use some approximations. Now this right here, instead of saying we're dividing by tangent of 37 degrees, we're going to say 1 over tangent of 37 degrees times h minus 20. And do the same thing over here. Instead of dividing h by tangent of 66, I'm going to say 1 over tangent of 66 degrees times h. Now why do I do that? So I can find these approximate values. So I'm going to divide 1 divided by tangent of 37, and we get an approximate value of 1.327h. And for 1 over tangent of 66, I do the same thing. And I get an approximate value of 0.445. So now, all I have to do is get h on one side. So what I'll first do is I'll add 20 to the other side. So I have 1.327h equals 0.445h plus 20. And then I will subtract 0.445h. And so then I will have h on one side. 1.327 minus 0.445. So we get 0.882h equals 20. So when we divide by 0.882, we get a value of 22.676 for h. Now in the next problem, here we're given a regular pentagon, and we want to find the area. Now a lot of people weird out at this problem, but really what I tell people is anytime you see a regular polygon, pentagon, hexagon, octagon, whatever, just in your mind, divide it up into a whole bunch of smaller triangles. So I'll do that. Now because this is a regular pentagon, all these triangles have to be the same thing. And so we have 5 identical triangles with a base of 6. Now what we do is cut them exactly in half. Draw the altitude for all of them. Now what we've done is we've now divided this pentagon into 10 identical right triangles. Well, what do we know about them? Well, this whole side is 6, so that means this side is 3. And we know that this is a right angle because we drew the altitude. And we know this angle because one full rotation is 360 degrees. And since there's 10 of them, we have to split it 10 equal ways. So that means we have 36 degrees right here. So really, this pentagon is really made up of 10 of these identical triangles. So if we can find the area of this one triangle, then we've got the area of the whole thing. So really, all we need is h, is our height. And so 3 right here is opposite, 36 degrees, and h is adjacent to it. So this is going to involve tangent. So tangent of 36 degrees equals 3 over h. So to get h by itself, we'll multiply by h. So h times tangent of 36 degrees equals 3. And then we'll divide by tangent of 36 degrees. So we have 3 over tangent of 36. And so that is our height. So for the area of one triangle, that's going to be 1/2 the base, which is 3, times the height, which we found. 3 over tangent of 36 degrees. So that simplifies to 9 over 2 tangent of 36 degrees. And so if I want the area of the polygon, well, like I said, there's just 10 of these. So all I have to do is just take 10 times the area we already found. 9 over 2 tangent of 36 degrees. And so that's going to be, let's see, 10 and 2 cancel, leaving 5. So that leaves 45 over tangent of 36 degrees. And if I find the approximate, tangent 45 divided by tangent of 36, we get 61.937 as our area. And so really, for any of these regular polygons, just imagine where's the right triangle inside it. Once you see it, find the sides that you don't know, find the area of that triangle, and then multiply by however many you've got. All right. Now on this last page, we want to label the sides and angles of a right triangle with one side of length x, so that x equals 12 sine of 43 degrees. Okay. So we've got some information here. And so x equals 12 sine of 43. Well, what would that be? What would sine of 43 equal? Well, we can find an approximation, but if I just divide it by 12, that means we have x over 12. Now remember, sine is opposite over hypotenuse. Okay, so that tells us something. So that tells us that the hypotenuse of this triangle has to be 12. And x has to be opposite 43 degrees. So 43 degrees has to be here, and x has to be here. And that leaves 47 degrees here. And I can use Pythagorean theorem to find the third side. So that's going to be a squared plus x squared equals 12 squared. So if I subtract x squared, I get a squared equals 12 squared minus x squared. And if I take the square root, a is the square root of 144 minus x squared. So there is the length of our third side. 144 minus x squared. Now down here, kind of the same setup. So we'll divide by 26 first. So cotangent of 20 degrees equals x over 26. Now cotangent's kind of an awkward statement. We're not very intuitive about that, but it's related to tangent. It's just the reciprocal. So if I turn that around, tangent of 20 degrees is 26 over x. Now tangent is the opposite over the adjacent. So that means the side of 26 has to be opposite the angle of 20. So if this is 20, then this has to be 26, and this has to be x. So that means this angle up here has to be 70. So if we want to find our hypotenuse, we'll just use Pythagorean theorem. X squared plus 26 squared equals c squared. And so the square root of x squared plus 676 is equal to c. So that is the length of our hypotenuse. Thanks for watching. If you liked the video, give it a thumbs up. For more videos like this, click the subscribe button. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching. Remember that the best way to understand something is to do it.